In this video presentation, we will discuss on how to construct a truth table. A truth table is a tabular representation of all the combination of values for inputs and their corresponding outputs. In this case, for our propositions, we will just use the symbol T for true or F for false. Sometimes, the use of other values such as 0 and 1 can be used in writing a truth table. Let's look at this example. This is a simple truth table. Let P be a proposition. As discussed in the previous lesson, a proposition can either be true or false. Now, getting the negation of P will give us the following values. If the proposition P is true, then its not P is false. And if the proposition P is false, then its not P is true. A compound propositions are propositions formed by combining two or more simple propositions. These propositions can be written as any symbol or any letters. For example, let the proposition I am a Tomasian be noted as P. And the proposition I enjoy flooded areas be written as proposition Q. Now, combining these two simple propositions, I am a Tomasian, I enjoy flooded area can be written as the following. You can write it as I am a Tomasian and I enjoy flooded areas. Or in the symbol notation, you can write it as P and Q. The symbol for and is like an inverted V. Next, you can also say that I am a Tomasian or I enjoy flooded area. Or in symbol notation, you can write it as P or Q or the symbol V. Lastly, you can also write if I am a Tomasian, then I enjoy flooded area. Or in symbol notation, that is P arrow Q. Now, let P and Q be propositions. The conjunction P and Q is true if and only if both P and Q are true. Otherwise, it is false. To construct the truth table for the conjunction, you have to set up the following scenarios. You can have both propositions are true, one proposition is true, the other is false, and both propositions are false. To complete the table, apply the conjunction rule. In this case, only row 1 have both true propositions. Hence, its conjunction is true. The rest of the table will be false. Next example, construct the truth table for the conjunction of not P and Q. Since in this example, you need a not P, you need to create a third table for that values. So getting the not P first, you will get these values. Now, taking the conjunction of not P and Q, by applying the conjunction rule, it will only be the third row that can be true. The rest will be false. Next example, construct the truth table for the conjunction of not P and not Q. Now, similar to the previous example, you need to add the following tables. So for not P, you have these values, and then for not Q, with these values. before solving for the conjunction of not P and not Q. Now, looking at the values of the proposition, you can see that the fourth row are both true. Hence, the rest of the table except for the fourth row will be false. Last example, construct the truth table for not conjunction of P and Q. So similar to the very first example, you can now set up the conjunction of P and Q, which is true, false, false, and false. Now, getting the negated proposition of the third column, that will give you false, true, true, and true. The disjunction of the propositions P or Q is false if and only if both P and Q is false. Otherwise, it is true. Setting up the truth table for the disjunction, you will notice that the fourth row has two propositions that is equivalent to false. Hence, the first three rows will be true and the last row will be false. Example, construct the truth table for P disjunction not Q. Now, getting first the not Q, you will have false, false, and true. Now, solving for the disjunction of not Q or P, you will notice that it is the third row that have both proposition equal to false. Hence, first row and second row will be true, the third row will be false, and the fourth row will be true. Next, construct the truth table for the disjunction of not P or not Q. Now, similar to the conjunction truth table, set up first the table for not P and not Q before getting its disjunction. Last example, construct the truth table for not quantity disjunction of P or Q. So you have to set up first the disjunction of P or Q before solving its negation. Now, let us compare these two truth tables. Notice that the last columns for these two tables have the same values. Now, we can say that the conjunction of not P and not Q is exactly the same as not disjunction P or Q. Similarly, with these two tables, we can also see that the last column of each tables have the same values. So we can also say that not conjunction P and Q is exactly the same as not P disjunction not Q. This is what we call the De Morgan's law. The De Morgan's law states that the two truth tables are exactly the same. Next, the exclusive disjunction of P and Q is true when exactly one of P and Q is true. Otherwise, it is false. Now, setting up the truth table for the following propositions, you just need to look for the proposition that has exactly one true. In this case, the second row and the third row will be both true. The rest will be false. Example, construct the truth table for the exclusive disjunction of not P and Q. So you need to get first the not P before taking its exclusive disjunction. The NAND or not end of propositions P and Q is false when both P and Q are true. Otherwise, it is true. Setting up its truth table, the propositions that are both true will be false and the rest will be true. Last example, construct the truth table for P, not and not Q. So first, you need to set up the not Q values before getting the not and truth table values.